Good afternoon, everyone. My name is Greg Mason. I'm the Nuclear Technical Director for Element Materials Technology, Element Nuclear from Huntsville, Alabama. And joining me is my colleague, Chris Stone from the Warwick, UK Element facility. And what we're going to discuss today is the capabilities of our facilities in providing a nuclear qualification testing. So just a quick agenda or introductions, and then we'll talk a little about Element Materials Technology, the UK capabilities, the Element Huntsville capabilities, and then innovations within the Element Nuclear Test Services.
Okay, good afternoon everyone. Chris Stone. I've been with Element for 20 years and had various roles in there, but fundamentally most of my time I've been involved with equipment qualification, seismic testing, vibration analysis, structural dynamics. I've worked for various companies including GEC, Alstom and Areva, which were originally nuclear companies, and we're qualifying a load of products from different industries within Element in the UK, but the thing that differentiates us largely is the seismic test facility.
And my nuclear career began in 1986 at the Farley Nuclear Plant in South Alabama in the US. I began my career in health physics. In 1991, I moved to Huntsville and went to work for Wiley Laboratories, which is still the facility I'm at today. So Wiley has a long history, 50 plus years in the nuclear industry providing testing services. In 2014, Wiley Laboratories was acquired by National Technical Systems, NTS Labs. I continued I had started a new role in business development at that time. Previously, I'd been in valve engineering as well as health physics still. And then in 2022, NTS was acquired by Element Materials Technology. And then earlier this year, I was named as the Nuclear Technical Director. So Element is a recognized leader in testing, inspection, certification services to a diverse range of industry sectors. We're located over in 30 countries, over 270 labs, 9,000 employees, over 55,000 customers, working in connected technologies, mobility, life sciences, environmental, aerospace, and of course energy. A number of the test capabilities here across the Element labs throughout the world with material testing, metallography, chemical analysis, and on and on. So mainly within the US, it's all about more environmental testing and material testing. In the UK, I believe it's much more diversified.
Yeah, so we've got facilities that look at modelling. So we do the full life cycle of a product really, from the initial design stage right through to decommissioning or to in-service failure analysis and that sort of thing.
Okay.
Great. Okay, so this just an overview of the main PQT, product qualification lab, that Element has based in Warwick in the Midlands in the UK. So it's got a broad range of environmental test facilities within, all under one roof. So that is temperature, humidity, all the climatic, sand, dust, vibration, shock, ingress testing and that sort of thing. So it's a one-stop shop for environmental testing, but we've also got sister labs that do EMC and seismic and solar radiation and that sort of thing, also in the UK. So as I said, what we're really all about is trying to partner with our customers, because Many years ago, we realised that actually the best outcome for both the test house and for the customer is to start discussions early, and that's what I would, if there's one message that I would like you to get from this talk, is to engage early. We have something called early stage qualification, where we want to partner with our customers. We will work with you to come up with the best strategy for qualifying your product. We'll write test documentation that you can then take to a competitor's test house if you want. But by that stage, we hope that you will have got a good, confident feeling of our technical expertise and will want to work with us through the actual qualification testing phase. So we've got capabilities for feasibility studies at the start, assisting you with the design, modelling and analysis, and then prototype development. And then our main areas of expertise, certainly within the UK and in Warwick, are model validation. So we can do modal testing, we can do tests to validate your digital models that you've already got, or we can develop models for you. And then we'll perform the qualification testing, provide you with certification, and then we can also look at in-service assessments. We can assess the environments that your product's working in or about to work in. And we can look at root cause design and failure analysis once it's in service. So this is just a few pictures of the facilities in our lab. So we've got a range of walk-in temperature, humidity, solar radiation facilities, which are operating sort of minus 40 up to 70 degrees centigrade with humidity. And then we've got smaller temperature humidity cabinets that do a higher ramp rate and a greater range. We've got 8 shock and vibration electrodynamic shaker systems, 3 186 kilonewton systems, so capable of testing up to 2 tons, up to 2 kilohertz as well. And then we've got a range of mechanical tests, shock testing, drop testing, impact testing. So the thing that probably differentiates us the most within the UK is that we have got a partnership with the University of Bristol, where we perform seismic qualification testing. We've got over 30 years of experience doing that, and we've run over 200 programs. So the 2 facilities that we operate are a 3-metre squared table capable of testing items up to about 10 tonnes. And then we've got a smaller hexapod system, which is specifically designed for testing component level testing. So that's acceleration levels up to 10, 11 G in the time domain. And that's for items up to about 800 kilograms. Both facilities can run vibration testing as well. And the smaller hexapod shaker system here, which is a 6 degree of freedom system, is also capable of running airplane crash testing, which is obviously now much more applicable within the nuclear industry. So this is just an example of, I've got 2 videos. One is a customer came to us and wanted us to just test his equipment cabinet as it was designed. And this is what happened. So this is a triaxial earthquake test for the UK. And as you can see, the cabinet frame itself wasn't stiff enough, so the doors opened. It lost a lot of its shear strength as the doors opened, and it cracked the actual cubicle chassis itself. We then worked with the customer. Obviously, although we're a test house, we've got a lot of experience in how to pass the tests as well. So we then work with the customer, and this is then the same cabinet, but with the stiffness increased at the base. So it's running exactly the same test. You can see that there's much less flexibility. The natural frequencies were increased from the zone of the seismic test where there was a lot of energy, sort of 2 to 10 hertz. If you get the natural frequency above 10 hertz, then you've got a much more likely chance of passing the test. That's just an example. We're using something that's visible, very visual, of how we like to work with our customers. You can see how the design can affect the test performance. Okay, so another thing that we have a lot of expertise in is the seismic test specifications, which are obviously evolving constantly. So this is just a flavour of some of the specifications that we carry out the equipment qualification to, particularly for the seismic testing. And then one of the areas that we work very closely with most of our customers is that most customers aren't performing seismic qualification tests very frequently and might not have done so previously, so they really are looking at the test houses and Element in particular to be beside them to talk to their customer about what the customer requirements are and come up with a credible test that strategically makes sense and more importantly can actually be carried out. Okay, so that's a brief overview of the facilities and what we do here in the UK. I'll pass you back to Greg for the US info.
Okay, so this is the Huntsville facility in Alabama. So we sit on 120 acres or so. Right now we have about 95 employees, over 300 plus customers on a routine basis. About 65-70% of our revenue is related to nuclear work. The remaining is mainly aerospace, defense, space type activities. So we in Huntsville, we have one of the largest flow test facilities in the world. We've qualified probably most of the valves that have been utilized in the nuclear industry over the past probably closer to 60 years now. The full flow system can flow just over 2 million pounds per hour, optimally at about 1,400 psi, max right now of 1,800 psi. We're working to make continued modifications to reach 2,500 psi for a pressurizer safety valve full flow. We can flow hot water, 600 degree Fahrenheit, water at 2,200 psi, hot or cold, or the hot for 600. We have a closed loop system with a 30,000 gallon tank. We have another closed loop system that's at ambient conditions at 60,000 gallons. We also have test cells where we're doing routine safety relief valve service work. 2 cells for up to 1,500 psi and 1 cell up to 3,000 psi, and that's with steam, air, or water. So with this, most of our testing for the valve qualifications under ASME QME1, again for air, water, steam valves. We also perform cycle testing, flow interruption, deflection, and modal testing. Go back here. Oh, so here we're doing some deflection and modal testing setup. The lower picture over here on the to my left is our full flow setup. And one of the things that we're well known for is, you notice it's a big concrete pad with buried I-beams. So what we do is reconstruct or fabricate whatever the customer needs. Probably the biggest thing we did, we recreated a whole pressurizer cavity and the valves to test at one point for utility. So this is a video of a jet impingement test. So what would happen with a pipe rupture, if a pipe ruptured in the plant at pressure? So as you can see, this piping is, we do different configurations, different insulations, and then sometimes we've even done like leaded blankets. And the intent is to see what's going to happen if there was a pipe rupture. So in Huntsville, we have 4 seismic tables, 2 back-seal tables, one back-seal table, 2 track-seal tables, and 1 single-axis table. So the back-seal table, that's a 60,000-pound diesel generator. We have a 20 by 20 plate there. The top one to my far left, 9,000 pounds. The track seal below it, 5,000 pounds. And then the single axis tables for line mounted devices. And that can be configured in horizontal or vertical. So this is on the back seal table, a gas-fired turbine. So one of our great capabilities then is also not just put an item on the table, to actually functionally operate the item during a seismic event. So we also in Huntsville have multiple EMI, EMC chambers. We actually have 2 LOCA facilities now. Our legacy, what we call our legacy facility for everything prior to Gen 4. We have 6 chambers to support that. The chamber to the right, that's our main chamber that we use most often. It's 6 feet in diameter, 8 feet deep. There's a superheater to deliver superheated steam and chemical injection. And then we also have for thermal aging. So we have various chambers for all environmental testing. And we also have dynamics tables for high frequency type single axis testing. So we're in the process of building what we believe is the first of a kind LOCA test facility that will support SMR. It'll have 2 help chambers and 2 LOCA chambers, one in a vertical and another horizontal position. So these are going to be so the legacy chambers were typically used at about 125 psi, 500 degrees Fahrenheit. These chambers are going to be capabilities of as much as up to 2,000 psi and temperatures 700 to 800 degrees Fahrenheit. So that should fold in the water-cooled SMRs as they start beginning their qualification testing for any harsh environment. So a short video, right now we're in a 3-year capital improvement where the company's invested $30 million. So again, the company has invested $10 million into the new LOCA facility, and then $10 million for infrastructure, new equipment and such, beginning this year at 2026 and 2027. So I wanted to add also, not in the Huntsville facility, but within Element, material testing is a large part of the business. Labs throughout the world, about 25 labs in the US, a number of labs in the UK. So for destructive and non-destructive testing, material analysis, elemental analysis, chemical analysis, mechanical metallography, and on and on. So that is one of the additions that became part of when we were acquired that a lot of customers are now take advantage of. So we want to thank you for joining us. Again, the main purpose of this presentation was to make the Element name more aware to the public as being in nuclear. Again, as Wiley Laboratories, we were very well known. NTS, not quite like Wiley, and Element, we're working on getting the word out throughout the world. So hope you'll join us for any questions you may have.
Yeah, I was just going to say one comment following on from the last presentation by LRQA. The one thing that we haven't put on here is that all of the labs are ISO 17025, so they're all accredited and internationally recognised. So they've COFRAC in France and all the authorities in the US as well.
So any details will be over here, can address those. We'll also, we're in the US Pavilion, we have an exhibit booth, and we're happy to address any specific questions you may have through the end of the event tomorrow. So thank you very much.
Yeah, thank you.